Hello, this is Samuel Academy. Welcome to my channel. In this video, I want to explain more about the concept of the gradient or the slope in mathematics for grade 9 students. Now, I've used modeling clay to make a model that I can use to explain the gradient. Alright? Now, we have the Cartesian coordinate plane in that model, which has got the y-axis and the x-axis. This is the y-axis, which runs vertically, and this is the x-axis. Alright? Now, where the two axes meet, where the x-axis crosses the y-axis, at this point, we have the point with x and y values as 0, 0. The value of x is 0 and the value of y is 0. It is called the origin. Alright? Now, in this Cartesian coordinate plane, the values of x along this line to the right of the origin are positive. So we have 0, positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, and so on. And the values of x to the left of the origin, okay, they are negative. We have negative values for x to the left of the origin. We have negative 1, negative 2, and so on. Now let's talk about the y-axis. The values of y above the origin are positive. This is 0, this is 1, 2, 3, 4, 5, 6, and so on. And the values of y below the origin are negative. So we have 0, negative 1, negative 2, and so on. Okay, that's the Cartesian coordinate plane. Let us proceed. Now we have this line, okay, which is drawn on this Cartesian coordinate plane, and this is a straight line, right? Now this straight line crosses the y-axis at this point. We say that the value of y at this point, where the line crosses the y-axis, is the y-intercept. So the value of y at this point, it is 3 in this case. So the y-intercept is 3, okay, at this point. Now, before I proceed, you find that a straight line has an equation. It has an equation of this form. If you can see this, y is equal to mx plus c. So this equation represents the value of y for a given value of x. So y is equal to mx plus c. In this case, m is the gradient of that line, and c is the y-intercept. So in our case, the value of c is 3. That is where the line crosses the y-axis. That is when x is 0, right? We found that the value is 3. Now we want to find the gradient of that line. And how do we find the gradient or the slope of the straight line? We find the change in y, then divide by the change in x. For example, in this model, the value of y at this point is 6. You can see this one is 6. So at this point, the value of y is 6. And at this point, the value of y is 4. So the change in y from here to here, all right? The change in y from here to here is given by the value of y minus the value of y2, for example, minus the value of y1. So the first value of y in this case, because this is the portion we are considering from here to here along that line. So we want to find the gradient of the line using this portion. Okay? So from this point to this point, the value of y at this point is 4. That is y1. And then at this point, the value of y is 6. That is y2. So to find the change in y, you take the second value of y minus the first value of y. That is y2 minus y1. In this case, 6 minus 4, you get 2. That is the change in y. So to get the gradient, you get the change in y divided by the change in x. So we have found the change in y, that is y2 minus y1. 6 minus 4, you get 2. Okay? From here to here, that's the change in y. Now the change in x is, in this portion, the second value of x here. What is x at this point? It is 6. All right? And then the first value of x is 2. Okay? Along the x-axis, we are moving in the horizontal. And along the y-axis, we are moving the vertical. So in the horizontal direction, we have the value of x here, which is 6. That's from 0, this one is 6. And from 0, this one is 2. So at this point, x is 2. And at this point, x is 6. So x1 is 2. And x2 is 6. So the change in x is equal to x2 minus x1. That is from here to here. x2 minus x1, or 6 minus 2, you get 4. So the gradient of this line using this portion is equal to y2 minus y1, that is 6 minus 4, you get 2, divided by x2 minus x1, that is 6 minus 2, you get 4. So the change in the gradient is equal to the change in y over the change in x, which is equal to 6 minus 4, which is 2, divided by 4, divided by 6 minus 2. That is 2 over 4. You get a half. So the gradient of this line is a half. Right? So let's say that in this equation of the straight line, y is equal to mx plus c, we now know that the gradient is a half. So the value of m in this equation is a half. And the y-intercept, we found it to be 3. So the equation of that line we will be looking at is equal to y is equal to mx plus c, or a half x plus 3. That is the equation of that line after finding the gradient as well as the y-intercept. All right? So let's say you have been given you have found the gradient and you do not know the y-intercept, but you have some two values, value of x and value of y. Let's say that the value of x is 0. X is 0 here. So y is going to be 3. Okay. So you have two values, value of x and value of y. So when x is 0, y is here, where the line cuts the y-axis is here. Y is 3. So you want to find the y-intercept because we have found the gradient as a half. So in this case, you find that you substitute the values of y and x in that equation. Okay. So where there is y, you write y. Okay. This is what I'm talking about. In that equation, we want to find the y-intercept. So we know that y is 3, okay, when x is 0, and we know the gradient. So that means 3 is equal to a half times 0, because x is 0, plus c. 3 is equal to, 3 is the value of y. So 3 is equal to half times x. X is 0. So half times 0 is 0. So we find that 3 is equal to 0 plus c. So that means the value of the y-intercept is 3. Okay. So, and how do you explain the y-intercept? Is actually the value of y when x is 0. That is where the line crosses the y-axis. When x is 0, y is 3. That is our y-intercept where the line crosses the y-axis. Thank you so much. Remember to subscribe to my channel as I make more models to explain ideas in mathematics and even in science. Thank you so much.